Okay, so we are starting 14.5 notes. This is all about geometric sequences or geometric progression. So just like we talked about arithmetic the other day, this is now geometric. And it's in the form of a times r squared, a times r to the third, where a and r are constants and r is called the common ratio. So whereas the arithmetic one was ones where you were adding a certain common difference each time, this time now you're multiplying by a common ratio each time. So each term in a geometric sequence is obtained by multiplying the previous term by r. Okay, in a certain geometric sequence, so let's look at example 1 here. Again, so geometric, you're always multiplying by that same number each time. In a certain geometric sequence, the first term is 2, the third term is 3, and the common ratio is negative. Find the second term. Okay, so the way I would set this one up is kind of use this generic format. AR squared, etc., right? The first term, they said, is 2, so A equals 2, right? The second term we don't know about, okay? It's sort of our question mark here. But we know since A is 2 that the second term is going to be 2 times R, okay? And then this third term, again, we know that A is 2. R we don't know, but it did tell us that this third term was equal to 3. So we can solve this little equation that we've come up with here in order to figure out what R is. And so R squared equals 3 halves. When I square root that, I get the plus or minus root 6 over 2, is that right? And be root 3, rationalize, root 2 over root 2, right? So I'd get root 6 over 2. Positive or negative, now they did tell you that common ratio was negative in the problem, and so I'll choose the negative one, okay? So I'll use r equals negative root 6 over 2. And then the question didn't actually ask you to find r, it asked you to find that second term. So now if I go back, this is my second term. And so it's asking me to find 2r, that would be my second term. So I just plug in negative root 6 over 2, cancel, and so my second term is just going to be negative root 6. This is one that's going to be really tricky to figure out without the formulas. You're like, okay, I've got this something, it's 2, and then blank, and then 3, and I've got to figure out what am I multiplying by each time, and it's a negative number in order to then get here. So it would take a lot of sort of extra difficult work to figure that out, but by setting it up using this formula, so memorize this, AR squared, AR cubed, etc. When you have something with just the first few terms, it's pretty easy to figure it out that way. To find the nth term of a geometric sequence, we've got this example, right? We noticed that it was AR to the 0, AR to the 1, AR to the 2, AR to the 3, so the nth term, and you can see that pattern there, would just be A times r. Now it's the fourth term gave us the third power. The third term, it was to the second power. The second term was to the first power. The first term was to the 0th power. So notice we're reducing by 1 each time. So this would actually be ar to the n minus 1. And that's our formula right here for the nth term of any geometric sequence. Okay, memorize it. So, for example, it wants us to find the 7th term of this geometric sequence. So my formula here is A sub n is A times r to the n minus 1. Well, I want the 7th term, so n is 7. So A sub 7 would be A times r to the 7 minus 1. We got to figure out what A and r are. Well, A is just the first term. So A is just 2. And R is the common difference between them, or sorry, the common ratio between them. So what am I multiplying by each time here? This one's a pretty easy one to figure out, right? And so R would just be 3, because I'm multiplying by 3, etc. So A is equal to 2, R is equal to 3. And so I'm just going to plug that in. So my 7th term is A was equal to 2. R is equal to 3, raise that to the 6th power, and so 2 times 3 to the 6th is some big number, that you can all figure out with your calculators. Okay. In this case here, r was pretty easy to figure out. I could just do that in my head. If you can't figure out r that easily, to find r, just divide term 2 divided by term 1. That will always equal r. Or term 3 divided by term 2. Or term 5 divided by term 4. Whatever it is, when you divide two consecutive terms together, you're always going to figure out what that common ratio is. Okay? So again, 6 divided by 2, that's what gave me the 3. So that's where term 2 divided by term 1. Okay, so that's a nice way, easy way to figure it out. All right, let's continue on here and now talk about sums for geometric sequences in series. So there's a couple more formulas, 2 more formulas. And again, you should have picked up the note cards last week that have these formulas. If you misplace them or do not have them and you would like note cards, they are still over on the windowsill. So the formula for the sum of a finite geometric, so this is where we are noticing a difference, right? A finite one, again, it has to terminate. So notice that this sequence terminates here. It does not continue, therefore it's a finite. Down here, we're going to have a different formula for the sum of an infinite geometric series. So for those ones, you'll notice at the bottom of the page, those ones are infinite. They've got the dot, 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 and they're continuing forever. All right, so this first one. Let S sub n denotes the sum of all of them added up. And so here's my formula. S sub n is equal to a times 1 minus r to the nth, all over 1 minus r. All right, well, let's figure that out. So for this one, again, S sub n equals a times 1 minus r to the n over 1 minus r. Well, what's my a? That's pretty easy. A is just my first term. So a is just 1/2. 1 minus r to the n. Well, what's r to the n? Right? Well, what's r, first of all? Right? What's r? Well, let's see. What's happening here? I have 1/2, right? And then I have 1/4. I'm going to write this out. I have 1/2, and then I have 1/4, and then 1/8, and then all the way up until 2 to the 10th. What's 2 to the 10th? 1 over 1024. Okay. So what am I multiplying by each time? Well, again, if you're not so sure, divide r is always equal to term 2 divided by term 1. Again, most of you could probably figure this one out, but I would take 1/4 and divide it by 1/2. So I do get that r is equal to 1/2. Unless you could figure out you're multiplying. Oh yeah, I'm multiplying by 1/2, multiplying by 1/2, multiplying by 1/2. Okay, so r is 1/2, but then it says to raise it to the nth power. Well, what's n here? Well, n is however many terms I went to, right? And so how many terms did I have to go to? Well, this was the first term, second term, third term, so this one was obviously the 10th term. And so I'm going to raise that to the 10th power. Okay. All over 1 minus r, right? And r again was just 1/2. And then we just have to work this out. So I have 1/2 over 1 minus, that was that 1024, right? Over 1/2. Oh, those cancel, so that's nice. And so then this just gives me a fraction. Now, could you have added these all up on your calculator? Yeah, probably. 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1, right? And just keep going until you get there and hit enter. And, you know, math frac, right? And you get this on your calculator. So your calculator will do it for you. But what if we have one with x's or with a's or variables and you can't plug it into your calculator and it's not so easy and it's not so nice to figure them out. So that's why the formula will work. Okay. Let's look at the formula for the infinite geometric. And for an infinite geometric, your absolute value of r has to be less than 1, so we have to be multiplying by a fraction. And I will never give you one where r is not, so it will always work in the examples I give you. Then the sum of the infinite geometric series, and again, notice the dot, 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 that's why it's infinite, is given by s equals a over 1 minus r. These are called series that diverge. Next year you'll learn a lot, that converge. You'll learn a lot about series that diverge versus series that converge. When r is less than 1, these are called a converging series. And so it's kind of interesting. If we take this series, 1 plus 2/3 plus 4/9, and we continue on forever and ever and ever, infinity, the sum of all those numbers added up together is just going to follow this formula. Well, a, again, that's just my first term. And so in this case, that's my a is 1. 1 minus r, well, what am I multiplying by again? Remember, to find r, take term 2 and divide it by term 1. So I do 2/3 divided by 1. Oh, that's nice and easy. R is equal to 2/3. So then I have 1 over 1/3, which is just 3. So how cool is that? That this series, if you added up those fractions continuing on and on and on forever, it would equal 3. Or actually very, 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 very close to 3. And it's what we call it converges to 3. Okay, last example is to use a geometric series to find a fractional equivalent for these repeating decimals. Okay, so this is kind of interesting. If you have your calculator, you can just type this in your calculator and do a math fraction, and it will get this to a fractional equivalent, right? But using a series is a good way for us to figure out how to write this by hand. So the way I want to do this first is I want to separate out the part that repeats and the part that doesn't repeat, right? And so when I write this sort of as, it's 0.4, the only repeating part, though, was the 5, 5, 5, 5, 5s, right? So the 0.4 I can kind of deal with separately, and I can deal with the repeating part then separately. The 0.4 we know is just 4/10. So that part's pretty easy to just rewrite. Okay, but how about that point? This was like 0, 5, 5, 5, 5, 5, 5, 5. Well, if I do each of them separately, so I just take this first one, right? That's like 5/100ths. And then this next one is like 5/1000ths. And then this next one, you kind of get the idea, is 5/10,000ths. Okay, and it's going to keep going forever and ever and ever. So what is this? This is an infinite geometric series right here. Right? Just like we saw in the example above. It's an infinite geometric series. A is equal to 5/100. R is just the common difference. Well, or the common ratio. What am I multiplying by each time? It's pretty easy. Notice that I'm multiplying this by 1/10, right? 1/10. And it gives me the next one. So R is just 1/10. So I can use my formula, S equals A over 1 minus R. So A was 5/100ths, and then 1 minus 1/10, because R is 1/10. So what is that? That's 9/10, so 5/100ths over 9/10. And I get, flip that one. I think when you reduce it, you get 1/18. Okay, for the sum, but that's just that part. But then we still had that 4/10 that we can't forget about. Okay, so the 4/10 was already out there. So I would take the 4/10 and add it to that 1/18, right, which was this whole part here. So this whole part converged to 1/18. And when I add those two together, common denominator, work it out, math frac, I think you get 41/90. And then what I would do on this problem is I would check it, and I would do 41/90, math, fraction, and let's hope that, oh, just kidding, I don't want it as fraction. I want it as a, oh, no batteries, hold on. I want it as a decimal, not a fraction. So I would do 41/90ths, and we get 0.4555555. So it works. So it's kind of cool, a nice little way to use geometric series to write those out. The next example, very similar. So it's the same idea here. We have the non-repeating part, which is the 0.2, and then this is 3, 5, 3, 5, 3, 5, 3, 5. That's the repeating part, right? Dot, dot, dot. So again, we'll separate it out into the two parts. So this would be 2/10. And then now this 35, it's not going to be hundredths because we're already to the third spot here, right? So this would actually be thousandths, 3 decimal places, and then I go 2 more, so this is not 10,000 but 100,000, right? So this had 3 zeros, this will now have 5 zeros. It's got 5 decimal places here. And then this next one will have 7 zeros. Okay, so you kind of get the idea that it's increasing a little bit bigger because it's double digits on top now. Okay, and so what will happen, this is dot, dot, dot again. So here's my geometric series. Right. Infinite geometric series. S is equal to A over 1 minus R. Well, my A this time is the first term, so 35 over 1,000. 1 minus R, well, what am I multiplying by? Over here I was multiplying by 1/10 each time. But for this one, notice I'm going up by 2 zeros, so I need to multiply by 1/100. 1 over 100 each time. And so my R is 1 over 100. And if you work this out and reduce it, trust me, using your calculator, you should get 7 over 198. So then I need to take that sum and add it together with the other guy. Common denominator, work it all out, simplify. You should get 233 over 990. And again, you can check it on your calculator. 233 over 990, it indeed is 0.2353535353535. So there you go. That is our notes for today. Homework is in your book. 7.5, I believe, is the assignment for tonight. Double check on the website.